Swayam Prabha. Digital India. Educated India.
Hello everybody, welcome to the course Reactive Intermediates, Carbenes and Nitranes. So, we are learning now different type of reactions of the carbene species. Up to the last class we have studied that different type of additions reactions. That means the carbene species, how does it react with olefin or alkyne, that we have studied, and additionally we have studied various type of examples based on that particular concept. Today what we will learn, that insertion reactions. This is another type of reaction. These carbene species generally goes through this type of reactions also, when there is different type of nucleophiles are there, that can be inserted into the carbene species. So, what is this insertion reaction? So, insertion reactions is a process in which a reactive intermediate, that is here like a carbene, imposes itself into a existing bond. Okay. So, this process, this is a process in which a reactive intermediate imposes itself into a existing bond. Okay. So, in general, if there is a bond, then if that reactive species inserted into it, then that is the insertion reactions. And as we know that carbenes are in general highly electron deficient. So, it wants a pair of electron to fill up its octet. So, that is why these type of reactions are very common with carbene species. As per example, we take this N-propene with the carbene species. So, this is a singlet. Then in this one step, because in this case these are concerted type of reactions. So, what it will give? Okay. So, here if we see there are these bonds okay. So, one of these CH2 singlet that has been inserted into this carbon hydrogen, here this carbon hydrogen bond, and that gives you this CH3 group over here. Okay. Now, if we take similar substrate with triplet carbene, okay. So, we can think that is like triplet carbene. Again this is a stepwise process, but eventually after first step this will give this methyl radical and this radical species, because this will pick up one H dot from here and make this one methyl radical, whereas here it will be like a CH3 CH dot CH3, and obviously after that hydrogen abstractions and recombination will give these two steps. First is this hydrogen abstraction followed by this recombination that gives the similar product. Okay. Now, in these two processes rather can give the same product, whether it is singlet or triplet. Now, as you know that singlet carbene will react in a concerted manner. Okay. That means, it can insert into a carbon hydrogen bond in single step. So, we will see now the orbital interaction during the insertion of a singlet carbene into carbon hydrogen bond. Okay. So, for that what we have to see? We have to see the highest occupied molecular orbital, or we have to consider it the highest occupied molecular orbital of carbon hydrogen bond and lowest unoccupied molecular orbital of carbene. Okay. So, let us draw that. So, we will first see the now these orbital interactions. Okay. So, first we will see the HOMO of this carbon hydrogen bond, where this carbene is getting inserted. So, that one we will see. Okay. So, let us draw that the field sigma bond orbital. This field sigma bond we will see. Okay. And as we know that from our previous experience that how this carbene LUMO that is proceeding, that is sideway approach. So, that will come like this way. In my previous one of the previous lecture I have explained what is this sideway approach. So, this is the empty p orbital and this is the field sigma. Okay. Now, if we see that the bonding interaction that can happen with this as well as with this. Okay. So, this is the CH bond HOMO and this is the CH bond HOMO. Sorry. Okay. And this is the carbene LUMO. Okay. So, in this way the sideway approach that can actually shows that how this singlet carbene can be inserted into a concerted manner. Okay. So, now once it is this one, then what will be this? We can draw in this way. Okay. Overall at this transition state. So, this could be the product okay. So, this we can see that here this field sigma bond and this empty p orbital they can nicely this highest occupied molecular orbital and the lowest unoccupied molecular orbital of carbene and HOMO of the CH bond they can be nicely give bonding interactions. Okay. Overall that means this carbene CH2 carbene that can be nicely inserted into the carbon hydrogen bond. Okay. Similar way we can see that this particular step can be obtained in opposite way. That means, that if we consider now carbon hydrogen bond LUMO, that is the sigma empty sigma star, okay. This is the hydrogen. So, this is the empty sigma star, okay. And if we take the carbene HOMO, okay, and their, if we consider their sideway approach, okay. So, now if we check its sideway approach again, that can nicely give this bonding interactions. So, either you consider this carbon hydrogen bond HOMO and carbene LUMO, or the carbon hydrogen bond LUMO and carbene HOMO. In these both cases, this will give you the bonding interactions. So, here it is empty sigma star and this one is filled sp2. Okay. So, these are the orbital interactions that actually shows that how the singlet carbene can be inserted into a carbon hydrogen bond. Okay. Additionally, this mechanism implies that the stereochemistry, that is the, if where this where this carbene species is inserting into the, if it is inserting into a stereo center, then the retention of configuration has been observed, or it is predicted, because this reaction is going via concerted manner. We will see now few of the examples where this carbene species has been inserted into a carbon hydrogen bond. As per example, if we take this particular diazo compound as a carbene precursor, okay. Now, you see, if we use this rhodium 2 acetate, here I am writing rhodium 2 catalyst, then what will happen, that first here writing Ln here. So, in this case it will generate the corresponding metallocarbene over here and give you the metallocarbene species, and once it will generate, what it will give? It will give you the corresponding 5 member cyclopentane type of ring, because if you consider 1, 2, 3, 4, 5. So, there are 5 member ring that will form. Okay. So, you can think about that. Okay. And this can be converted into a natural product in further steps. Okay. And this name of this natural product is alpha cuparinone. So, what we have done here? We have taken a carbene precursor, that is the diazo keto ester compound, that means this diazo is flanked with 2 electron withdrawing group, and then with the treatment of rhodium 2 catalyst we can generate the carbene metallocarbene, and now this carbon hydrogen bond that is over here, this one, in this the diazo ester keto compound, that means the precursor of the carbene, that can be inserted now into this carbon hydrogen bond to form this particular 5 member species. Okay. And if you see here, interesting thing is that this stereo center, that is the retention of configuration is happening. Okay. So, in similar way we can see another example where the sulfone type, sulfone has been used as the carbene precursor. So, the diazo is flanked with ester and the sulfone moiety. Now, if it is again under rhodium 2 catalyst. So, in that case this can be used as to generate the metallocarbene and to provide the corresponding cyclic product after the carbon hydrogen insertion. Here interesting thing is that here in this, okay, so this will insert that metallocarbene, that will insert into this particular carbon hydrogen bond. So, overall the product will be here okay. Here interesting thing is that even though there is a olefin, but the carbene that is not giving any addition product or not giving the addition product as a measure, rather it is going through the CH insertion reactions, because here it is forming the 6 member ring. Okay. And this again, this particular substrate which we have synthesized from this precursor through the rhodium 2 catalyzed CH insertion reactions, that can be converted into another natural product in fewer steps, that is this one. Okay. And the name of this is bakuchiol. Okay. So, you can see how much important this CH insertion reaction is, because using this particular technique there are several important reactions that can be carried out and which can be the advanced intermediate of various important biologically active natural products. Okay. Next we will see another type of reactions where the CH insertion reaction will give us the cyclopropane moiety. Earlier what we have seen, that the carbenes that can be inserted or that can be reacting with the olefins to give us the cyclopropane ring, whereas here we will see that the carbenes, how that is by CH insertion is giving the cyclopropane ring. As per example, we can take this substrate where there is no beta hydrogen. Now, if we use one of the Schlosser's base, okay. So, that proton will be abstracted from here and give us the lithiated salt. This okay. So, once we have this species, then by alpha elimination this will give the corresponding carbene species. Okay. Okay. So, now you see this methyl that is having 3 hydrogen, okay, we can draw in this way. Okay. Now, the CH insertions will happen, okay, to give us the corresponding cyclopropane derivative. Okay. So, here what is happening? Here the CH insertion is happening. So, in this case by CH insertion we are getting 3 member ring, because there is no beta hydrogen present here, and once there is no beta hydrogen, so that means this is forced to getting this alpha elimination, and once this alpha elimination is happening, then the carbene species is forming, and once this carbene species formed, then it is forced to go to the CH insertion to give the product with cyclopropane ring. Okay. In these cases, this type of insertion CH insertion reactions, it has been found, even the carbene species is so much eager, it is having so much eager to get the electrons that it will even react with the solvent. As per example, if there is a solvent like cyclohexane, that will be inserted into the carbon hydrogen bond of cyclohexane and give the corresponding product. So, if we have this type of diazo compound as the carbene precursor, then if the cyclohexane is solvent here, okay, so this will give the corresponding carbene, and once it will form, then this is highly electron deficient. Now, it can nicely insert into a carbon hydrogen bond of cyclohexane. Okay. Okay. So, once it will go like this, sorry, we will draw in this way. Okay. So, if it reacts with this carbon hydrogen bond of cyclohexane of this carbene species, finally what will be the product? So, the product will be the corresponding inserted product. Okay. So, here what is happening? Here also CH insertion is happening. Fine. Now, as we mentioned that carbene species are highly reactive, and if it is very much reactive, then there is a high chance of getting less selectivity. And in, as for example, if we take that heptane, okay, and under the diazomethane in photolytic photolysis condition. So, this will give various carbon hydrogen bond insertions. It will, you will see that in various positions of this heptane, the CH3 group CH2 carbene that has been inserted, and overall it will give this is as 38%, whereas this one will give 25% and another isomer is 24%. Okay. So, this will also form certain amount. So, these are the thing that we have to understand, that how these carbene species become so much reactive that it can be inserted into various position of this heptane to give many products. Okay. So, this is will be, I will rather remove this, the percentage of these products. We can say that these are the mixture of products that we will get from this particular reaction. So, mixture of products. Okay. Finally, if we see another example where again diazo compound is the precursor for the corresponding carbene. So, in presence of rhodium 2 catalyst, again the CH insertion will happen from here. There are 2 hydrogen, and if you see 1, 2, 3, 4, 5. So, 5 member ring can form, and overall the product will be the corresponding 5 member fused product. So, in that all way whatever we have shown, we can understand that this carbene species nicely can be inserted into the different type of carbon hydrogen bonds, especially as these carbenes are highly electron deficient, it prefers to insert into a electron rich carbon hydrogen bonds, and even though there are not that much electron rich, there also it can be inserted. So, these are the speciality of the carbene species to react with various type of carbon hydrogen bonds with different type of electronic properties. Thank you.